guys, today I'm going to be walking you through the examples from exercise 3.5 of your Year 11 Jacplus textbook. So this is where we have to make graphs of the quadratics. So if you haven't done so already, please do check out the transformation table video because that's going to help you to understand a lot of what we're doing here, especially for this first question. So they've got three equations and three graphs, the blue, the green and the pink one. So I'll start with the blue graph here, and what I see is that from the parent graph, or well, the original, you could call it y equals x squared, it's moved over. So this one, the blue graph, has moved over, so it's sitting at 3. So we've moved in the positive direction of the x-axis, and this means that the equation is going to be x minus 3 squared. So notice that it goes the opposite way for the horizontal, and that's something you'll learn about when you do transformations later on. So C would be the blue graph. So I'll match A with C. Let's go to the next one. So the parent graph can stay there, and let's do perhaps the green graph. So what's happened here is that it looks upside down. So again, we think what's happened to the parent graph to turn it upside down? Well, it's a reflection and it's negative x squared. It could be fatter or skinnier because we don't have a y equals x squared here or here, or negative x squared here or here. And it's certainly not this because that moves up from here, that would move up to 3. So it's definitely not A, it has to be B. And this 3 here represents a dilation. So it could be that the green graph is dilated, so it's skinnier than the original parent graph. So this means that graph C will match with example B there. Well, obviously graph C is graph B is going to be A, but let's look at Y. So this one has flipped, but it's also moved up to 3. So this is going to be y equals negative x squared. It's gone up by 3 units. So that's why we get A. So that's that. Let's move down. And now they're asking us to sketch this graph here. And again, the transformation video is going to be really important for you as you learn how to sketch from turning point form. So this is in turning point form. And the reason it's in turning point form is we can identify the turning point. And the turning point is going to be the opposite of what's in the brackets with the x, and then the same as what's outside the brackets. So negative 1, 8 would be our turning point. So you can see that straight away from this graph. Now, what I'm going to do is I'm going to do each of the transformations separately. So if we start with the parent graph, that would be our y equals x squared. And then the idea is that we've got to change that y equals x squared into our actual equation there. So at the moment it doesn't look too similar at all. So the first thing we do is dilation. And look, dilation and reflection are like the multiplication and division in BODMAS, so they come first. We must do them first. So the dilation is represented by this 2 here. So I'm going to colour code it in green. And what this means is the graph's going to be skinnier. So y equals 2x squared. And you don't really have to worry too much about the dilation because when you find your x and y intercepts, that number 2 is going to change the shape or change the intercepts. So we're not drawing to scale, we're not drawing on graph paper, so no matter how we draw it there, it's just a sketch. The next thing I'll do is the reflection, and the reflection is represented by the negative there, and like we saw in the first example, well, that's going to turn it upside down. So we're taking that skinnier graph there and turning it upside down, and that's going to create y equals negative 2x squared. So we're getting there. We've got negative 2x squared. The only things left are the +1 and the +8. So let's go for the +1. So this is our horizontal shift. And as I said, if it's in brackets with the x, so I'm going to say it's connected to the x. and it goes the opposite direction. So when we move our green graph to, I'll make it purple, to this purple graph, we're going to be moving in the negative direction by 1 unit, not the positive direction. So taking the green graph over to look like this, and this is going to be at 1, 0 at this stage. So this is now representing y equals -2, x plus a 1 squared. So we're almost there. There's just one more transformation that we need to take into account. We'll color code that yellow, and that is, I think we've already used that one. How about this? So that is this +8 here. And as we saw before, we know the turning point already is at -1. Oh, it's a negative, not a positive. -1, 8. So this +8 here is going to be taking the graph up by 8 units. So we take this graph and we just move it up 8 units. So that means that our x value is -1 and the y value is 8 for the turning point. And this now is y equals -2, x plus 1 squared plus 8. So what we don't know yet is where the y-intercept and x-intercept on this side are going to go. So what I mean by that is it could look like this, or it could look that it goes over to there. So we'll find that out now. So I'm just going to put this part on, and we will find out where we go depending on whether the x and y intercepts are positive or negative. So this was the vertical shift, by the way. Okay, so let's find the x and y intercepts, and I would recommend finding the y-intercept first. The reason is because it's pretty easy. You can go wrong, but not too easily. So if I find the y-intercept first, then I've got the shape, I've got the turning point, and I've got the y-intercept. So they're 3 out of 4 things that I need to show, rather than if I stuff up the x-intercepts and run out of time, then I've only done 2 of the things I need to show. So I have -2, 0 plus 1 squared plus 8, and that's going to equal y. So y equals -2 times 1, 1 squared is 1, plus 8. Y equals -2 plus 8 is 6. And what you want to be careful of here is, well, in some examples, when your equation is written out not in turning point form, like just say you had y equals 3x squared plus 2x plus 1, well then you can immediately see that the y-intercept is 1. So you don't need to do really any working out, because when we sub in the 0 into these, well, they're going to just be cancelled out. So what you're left with, y equals 1. When we do one that's in turning point form, that's certainly not the case. So we do need to sub in and be careful there. So our y-intercept is 6. I'm going to put that onto the graph. So that means that it's going to go like this. And notice that we should always write our equation, or our coordinates as coordinates. So x, y values, not just, put a little dash and write a 6 there. That's not good. They will never say don't write coordinates, but they will sometimes tell you to write coordinates. So if you don't write coordinates, you'll lose marks. So look, the last things we need to find are the 2 x-intercepts, and I can see that I've got 2 x-intercepts here. Sometimes you'll get 1 x-intercept, sometimes you get 0 x-intercepts. So let's find our x-intercepts. X-intercepts when y equals 0, so that means -2, x plus 1 squared plus 8 equals 0. And if I were you, I would go about this by undoing the equation. You could divide everything by 2 and then do a difference of perfect squares to factorize, but I feel that undoing is more appropriate when we've got it in turning point form, and probably easier, well, actually definitely easier. Let's divide by -2, and we get x plus 1 squared equals 4. Let's square root both sides. X plus 1 equals plus or minus 2. So don't forget the plus or minus. And x equals, now I'm going to minus 1. So that means +2 minus 1 and -2 minus 1. So that's going to be 1, and this is going to be -3. So as we saw when we drew it there with our positive y-intercept, we have a positive and a negative x-intercept. So what were they? -3 and 1. and again I'm writing them as coordinates. So there is our graph from turning point form that we have been able to do using the table of transformations and then just finding the intercepts. Okay, so the next one, this is still worked example 14, so it's just the second part. So now they're telling us to put the equation into y equals, into turning point form here. So look, I probably should have mentioned in the previous one that you should make a little list of the features that you want to include in your graph. And the features that we want to include are the x-intercepts, y-intercept, the shape. So when I talk about the shape, I'm talking about whether it's positive or negative, so what the smile or frown shape. And then we have our special feature, which is a turning point. So all these three are included in any graphs that you will do in Year 11, x-intercepts, y-intercepts and shape, and then you have a special feature. And for quadratics, that is our turning point. So look, let's put this into turning point form, and that will involve completing the square. So to complete the square, I need to take the 3 out because we have to have nothing in front of the x squared. So I've taken the 3 out. Let's complete the square. X squared minus 4x plus half of minus 4 is negative 2. Negative 2 squared is 4. So this is the square, and we've talked about that in a lot of detail in the video on completing the square. So I'm not going to go into it too much here. So that's the square. That's what we can factorize. That's a squared minus 2ab plus b squared, and that's the whole idea. We can create that. Now we've added a 4 on out of nowhere, so we need to subtract that 4, and then of course we've got this plus 6 on the end. And notice that we've taken the 3 out, so we're not looking at this 18 anymore. So don't get confused. We are looking at this 6 because the 3 is already accounted for over here. So let's neaten it up. Y equals 3. This is a squared minus 2ab plus b squared, so that factorizes to a minus b squared. And then negative 4 plus 6 is 2. Still all multiplied by 3. So we're almost there. This here does not have big brackets or square brackets which encompass the k, so we don't want it either. So let's remove the brackets, which means that we are still multiplying by 3 if we put the x minus 2 squared next to it, but it means we actually need to multiply this 2 by 3. So we get plus 6 here. So this is our turning point form. So now we can go about, well, I guess answering the question. They say to state the coordinates of the vertex, and the vertex is just the turning point, just another word for it. So the coordinates of the turning point or vertex is going to be the opposite of this, 2, and the same as this, 2, 6. So turning point, let's give that a tick because we already know what it is. And let's deal with the shape, which is going to be a positive. So this is a positive graph because there's no negative in front of the 3x squared. So the shape is going to be a smile. So we've got that. The y-intercept I'm going to do next. So y-intercept x equals 0, and I can sub this into either the turning point form or the original, but as I was talking about before, it's actually a lot easier to do it from the form here because, well, the y-intercept is 18. When you sub a 0 in, you get rid of all those x's. I'm going to write it out just to make sure it's clear, but you don't really need to. So y equals 18. So that cancels because they're both 0. So our y-intercept in coordinates is 0, 18. And then all we're left with is x-intercepts. So even if you didn't get a chance in a test or assessment task of whatever sort to do the x-intercepts, you could get 3 out of 4 marks for this because you have got 3 out of the 4 features. So look, let's do the x-intercepts. Now remembering there could be 1 x-intercept, 2 x-intercepts, or no x-intercepts. We will find out. So that will be easiest to do from turning point form. If we do it from the original form, we're going to need to cross-factorize, and that's fine, we can do that, but I feel that, you know, the turning point form is really quite easy to undo. So 3x minus 2 squared plus 6. equals 0. So it's minus 6 on both sides. So 3x minus 2 squared equals negative 6. Let's divide by 3 on both sides. We get x minus 2 squared equals negative 2. Now we encounter a little bit of what you might feel is a problem, or you might not notice when you're doing these. You can't root a negative. So if you can't root a negative, that means we don't have any x-intercept. So no x-intercepts. And look, we'll see when we draw it. Sometimes, if you make a small mistake, like when we completed the square, if we make a small mistake or something, then you might see, that you actually do have x-intercepts. But by drawing it, it will make a lot of sense. So we've got a turning point at 2, 6. So let's say 2 is here, 6 is here, so it can be there. We know that the y-intercept is 18. And, well, the shape is the smile shape because it's a positive graph. So we can see not only from the algebra and the fact that we can't root the negative, but also from, the logic of putting all the other features together, there are no x-intercepts in this graph. So we have considered x-intercepts, but there are none. All right, so that's that one. Let's move forward. Okay, so another sketch. So I'm going to write my list of features, which I should always do. So x-intercepts, y-intercept, shape, and the special feature, turning point. So it's a negative graph. I can see straight away the shape is going to be the frown. And look, I'm going to do this time the x-intercepts first, because it's going to be pretty easy to find the x-intercepts. So you always do the easiest first. And in this case, I'm choosing x-intercepts because I can basically see what they are straight away. So negative half, x plus 5, x minus 1 equals 0. So if I divide everything by neg half, that's just going to get rid of the negative half. And then we can solve each of these. X plus 5 equals 0. That means x equals neg 5. And x minus 1 equals 0. That means x equals 1. So the x-intercepts that time was super easy. So we've got negative 5, 0. Remember that we want to put coordinates, not just the numbers, 1 and negative 5. Okay, I'm going to do the y-intercept next. So y-intercept, that's where x equals 0. So we got y equals neg half. X plus 5, x minus 1, and I forgot to turn them into zeros, so I'll do that now. So that gives me negative half times 5 times neg 1. So negative half times negative 1 just gives us positive half. So it's going to be 5 over 2. So our y-intercept is at 0 for x and 5 over 2 for y. So we're almost there. The only thing we need is the turning point, and you could expand this equation here, and you could, put it into turning point form, but that would be quite a lot of work when really all we need to do is know that the turning point x value is in the middle of the two x-intercepts. So for the turning point, the x value is halfway between x-intercepts. So x value of the turning point is going to be, we take the two x values, negative 5 plus 1, we add them together and divide by 2. So it's like doing the average. Negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. So this means that for our turning point, we have the negative 2 for the x. What we're missing is the y. And really, now we can just sub that x value into the equation to find the corresponding y value. So let's do that. Y equals negative half, x is negative 2 plus 5, and negative 2 minus 1. Just double check that that was them. Yes. So let's solve that. Y equals neg half. Negative 2 plus 5 is negative 3. Negative 2 minus 1 is negative 3. So negative 2 plus 5 no, positive 3, sorry, and negative 2 minus 1, yep, negative 3. So 3 times negative 3 is negative 9. And negative half times negative 9 is positive 9 on 2. So notice I'm not going to make that 4.5 or anything like that. I'm just leaving it as an improper fraction. And I can add that to my turning point information. There we go. And now I've got everything I need to draw the graph. So let's do that. Y and x, and our equation is y equals negative half, x plus 5, x minus 1, and x-intercepts negative 5 and 1. Let's put those on. So negative 5, we're not just going to write it like that, remember. We're going to make it coordinates. You will never lose marks if you put coordinates. You may lose marks if you don't. Next, y-intercept is 0 and 5 on 2. Okay, 0, let's put it here. And the turning point will be somewhere here. So look, I might do the turning point first, because then the y-intercept will sort of be in, make itself known. So look, obviously it's not an amazing shape there. It would be nicer if it was a bit more curved on this side. You know what, I might just do that. So let's see. No, it's more like it. So 1, 0, and what do we say? 0 for x and 9 on 2 for y. And look, be careful that you don't accidentally write the y value where the x value should be. That's another thing people like to do. Okay, so we've got the turning point negative 2 and 9 on 2. And I just realised that I've written 9 on 2 there. I think it's meant to be 5 on 2. Let's double check that. Yes. So this is our graph complete with all important features, x-intercept, y-intercept, turning point, and the correct shape. Let's move on. I think it's the last one. Yes, it is. So this one's talking about the discriminant. So remember from a previous exercise, the discriminant equals b squared minus 4ac. And we get those a, b, and c values from the equation y equals ax squared plus bx plus c. So it tells us to determine the number and type of x-intercepts of the graph defined by this. And this has quite big numbers there, which is a little bit annoying. A equals 64, B equals 48, and C equals 9. So we can sub it into the discriminant, but it's not very nice. We're going to have big values. I might have to do that on my CAS. So B is 48, so 48 squared minus 4 times A, which is 64, times C, which is 9. So look, I will do that on my calculator. Okay, so this is going to be 2,304, 48 squared, and all right, so 2,304 as well. So what we get is the discriminant equals 0, and let's think about what that tells us. It means that there's going to be one solution. And, well, instead of writing solution, we can probably write we should write x-intercept now, because we're actually dealing with the graphs. So we're not solving the equation, we're drawing the graph. So the solutions are x-intercepts, or roots on your CAS, we'll call it a root, and it's one x-intercept there, and that x-intercept will be rational. So now that we've got that, so we've done A, now I want to sketch the graph. So it's a little bit of a tricky one actually, because of the numbers being so big, but why we had to do this first to find that there was one rational solution. This gives us the clue, and the clue is that it must be a perfect square. Well, it is. Well, I guess I should write that on the equation rather. So we might do y equals 64x squared plus 48x plus 9, and this must be a perfect square. If you have one solution, it means that it's a perfect square. So in that case, that means this is a squared plus 2ab plus b squared. And if I hadn't found the discriminant first, then I wouldn't necessarily have recognised that. It would have taken a little bit of thought there. You know, and if you're cross multiplying, you'll eventually get it, but it would be quite a pain. So finding the discriminant first was actually a really good idea. So let's see. I'm going to factorise this to a plus b squared. So it'll be a is 8x plus b must be 3 squared. So that's my my equation. So let's make our little list of features. X-intercept, intercept only one, y-intercept, shape, and the special feature for this type of graph, the turning point. So, well, I can see that my, the shape of it, it's a positive, so that means the shape is going to be a smile. So our x-intercept is going to be the turning point. So the graph will look something like this. If there's one solution, it's got to just touch the axis, the x-axis there. That's our one solution. And notice that it would just be one of those. I'm just showing all the different possibilities we could have. So look, let's go for the x-intercept. And that's going to be 8x plus 3 squared equals 0. So I'm going to square root both sides. And this is why it's a perfect square, because the square root of 0 is 0, just one solution. You don't have plus or minus 0. And then 8x equals negative 3, x equals negative 3/8. So we have one x-intercept, and we know that that has to be the turning point as well. So neg 3/8, comma 0. And then, well, let's get the y-intercept. Y-intercept, x equals 0. So that is 8 times 0 plus 3 squared. Y equals, so let's see, y equals 8 times 0 is 0. So 0 plus 3 is 3 squared, which equals 9. So our y-intercept at 9. And then this turning point is going to be the x-intercept, but I'll draw it so you can see what I'm talking about. So negative 3/8, and it was 9, I believe. Oops. Always in coordinates. And you see, for one x-intercept, of course the turning point has to be the x-intercept, because if I have an x-intercept there and then I go under, the only way I can come up and make the shape right is by having another x-intercept, and we don't have another x-intercept. So this would be our graph of y equals 8x plus 3 squared. So the turning point, neg 3/8, 0. And look, just to point out, this is written a little bit, this is a little bit weird, this one. You are not going to say that the turning point is negative 3, 0 because of this 8. So that 8 kind of ruins it for us. And I'm not going to go into that now, but just, you know, for the sake of this, I just wanted to point that out. So look, that's all the examples from 3.5. You might like to look back at other videos for things like, you know, perfect squares, completing the square, and the transformation video.